We can all agree on this. Spheres are a challenge. If they need to be really round, how do you do it? Obviously, you start with a cylinder, which the lathe makes pretty easy. But where do you go from there? How do you control the shape? Today, we will demonstrate an approach that takes all the guesswork out of the process and does it without resorting to specialized jigs and tools. Our club, the Santa Cruz Woodturners, asked a pro, John Wells, to show us exactly how it's done. He's going to turn a ball attached to a post, such as you might see on a staircase, like a newel post, a situation where multi-axis turning simply can't be done. But before John starts cutting, a diagram will help to understand the geometry that he uses. He starts with a cylinder and measures its diameter accurately. He then marks a section that is 1 diameter wide and squares up the ends of the cylinder. He doesn't draw a circle on the wood because that's not helpful during turning. But with the magic of video, we're going to overlay the outline of the sphere onto the cylinder so that you can better visualize the process. We want to cut away this triangular section of wood. To do this, mark the corners of the triangle. We'll call this distance A. Then, turn away the wood in the blue shaded area, leaving a straight line between the two marks. Repeat the process at the other end of the cylinder. You can see that the octagon that results is already reasonably close to a sphere, and it's perfectly symmetric. Now lay out another set of marks that will take off the corners of the octagon. The procedure is the same, but we will remove much less wood. We will call the distance from the corner B. Do this marking process for each corner that you can reach, and turn away the smaller shaded areas. How do you figure out the exact length of A and B? They are determined by the diameter of the finished sphere, and the easiest way to measure the diameter is here, where you can take it off with calipers. To get the length of A, just multiply the diameter by 0.293. Very few woodworking projects require 5 decimal places, but here is the precise figure for those of you who are NASA engineers. To get B, just multiply by 0.108. You can do the arithmetic on the calculator on your phone. All right, let's watch John Wells make short but very precise work of this. He has copied the dimensions from his scale drawing onto this scrap of wood, which is really handy if you're doing multiples. He also marks the location of the finial that forms the base for the ball. He then cuts the lower end of the cylinder squarely, measuring with calipers to leave sufficient wood for the finial. He cuts the top of the ball blank squarely as well, leaving just enough wood for the lathe center to hold. You could use a digital caliper to lay out the cut marks for both the A and B lengths, but John uses a small story stick, like this. The A distance is marked with a pencil, and the width of the strip is planed to be exactly the width of the B dimension. Remember that he has to mark not only the surface of the cylinder, but also both ends with the A dimension. He cuts away the corner in several controlled passes. Notice how each pass leaves a straight path at roughly 45 degrees. The last pass will leave a straight line between the two A marks. He's also made a simple 45-degree template to double-check his progress. Of course, the other end of the cylinder is just more of the same. John is using a 9/16 spindle gouge and making certain to leave crisp corners, which will be needed for the next step. Now he turns to the B end of this story stick and marks the distances from each of the new corners. Because John wants to include a finial to support the ball, he cannot lay out the final B mark. Again, it's important to cut a straight line from one B mark to its companion. The tenon that connects to the drive spur needs to be narrowed to create room to finish the B cut at the top of the ball. Because the space is tight, John uses a skew to create the final straight line cut. At this point, the sphere appears to be almost completed. All that's left is to smooth out the tiny bumps between the straight line cuts. John used the wing of a spindle gouge as a scraper, taking extremely shallow cuts to create a smooth curve. The shavings that are coming off are so thin you can hardly see them. He then turns the finial to a pleasing shape. And the project is ready for a little finish sanding. That's it. It's that simple, and yet a near-perfect sphere. Thanks, John, from the Santa Cruz Woodturners, and thanks to you for watching our video.